This video is going to talk through question 1 and question 5 of the distance time graph worksheet that you've been given. So just to start off here, all the graphs are a similar layout there. The time on the x-axis. Here our time is in hours, starting at 9 o'clock and going up to 11:30. Distance is on the y-axis, and here our distance is in miles. And if we look, I have our speed equation, which we were using last week on the speed equation sheet. Speed, okay, is distance over time. To find time, take distance and divide by speed, and to get the distance, we have speed multiplied by time. So we might not have to use that equation for this question, but we will for question 5. So if we look here, question 1 is telling us that this graph shows the journey from a class to the zoo, and we're told they stopped for a picnic on the way to the zoo. Okay, now if something stopped on a distance time graph, or if it's stationary is another way of saying that, or at rest, we know that in that the line is horizontal. Okay, so you think if something stopped, the distance isn't going to change, but the time will continue. Okay, and if we look here on this graph, we have a horizontal part of the graph here in the middle, and that's where they were having their picnic. So if we go through our questions here, first one we're asked, what time did the bus leave the school? Well, our journey here, the graph shows our journey, and the journey seems to start here at 9 o'clock. So that would be a reasonable answer for our initial starting time for this journey. Okay. Question B, what time did they stop for a picnic? Well, here, our horizontal part is where they've stopped in their journey. And if we look, it starts at 10 o'clock. So they travelled for an hour before they stopped for a picnic. C, how far had they travelled when they stopped for a picnic? Well, if we're asked about how far something's travelled, that's the distance. So our distance is on our y-axis. And if we look again, well, we've kind of decided that it stopped at 10 o'clock whenever the line becomes horizontal. And if we go across to our y-axis, that's going to tell us the distance is travelled. And we look here, it's halfway between 40 and 60. And that would be 50 miles they've travelled. So 50 miles. D, we're asked how long did they stop for. So again, we know that they've stopped at 10 o'clock. The horizontal line goes across two of the large squares before it starts to rise again, before has a diagonal gradient. And if we go down from where the line stops being horizontal and starts to be diagonal again, we go down, we see that that's at time 10:30. So if it stopped at 10 and they restarted their journey at 10:30, that would give us 30 minutes. Or you could also write half an hour there. E, what time did they arrive at the zoo? Well, we're assuming that this shows us the whole journey. And so the end of their journeys when they're at the zoo. And if we go down to find the time, it says 11:30. And finally F, how far is the zoo from the school? Well, again, if this is the end of our journey, okay, we found the time that they were there. How far is a measured distance, and distance is on our y-axis. So if we go across here to our y-axis, we'll see that the end of our line is halfway between 80 and 100 on our y-axis, and that will leave us with 90 miles. This is question 5 from the distance time graph worksheet, and this is slightly different. The numbers are a little bit more challenging, and we actually have to use our equation there, our speed equation, for 2 of the questions here. So if we start off here, you probably notice already that it's a little bit different, that the graph is not starting at the origin here. The line starting a little bit over on the x-axis, and the same layout as question 1. Again, we have time on the x-axis and we have distance on the y-axis. Here the distance is in kilometers, so that means our speed should probably be given in the units kilometers per hour, and we'll look at that whenever we get on to question B and question D. But look here, really we're told Laura goes for a cycle from our house to the post office 4 kilometers away. Okay, so if we look, there's 4 kilometers on the y-axis. She cycles up to the post office. The horizontal line tells us that she's stationary or at rest, so she's in the post office during this time. And then the line shows back down to 0, so she's going back to her house. Okay, so we're going to need to use all those little points on this. So the first question we're asked, question A, how long did it take Laura to cycle to the post office? Well, look here, she's at the post office once the line begins to become horizontal at 11:20. But the challenge here though is she doesn't start at 11. Okay, she starts her journey halfway between, will be 11 and 10 past 11. So halfway between here will be 5 past 11. So that means it took her, there's 5 minutes, 10 minutes, 15. Okay, or 11:20 to back to 10 past 11 is 15 minutes. Now, the other thing to bear in mind here is because we're working with speed, I'm just going to do this now because it'll help us on our next question. Particularly if you see kilometers and speed questions, we're going to want to define speed. We want distance divided by time. Okay, but to have our speed in kilometers per hour, we need to divide that distance by a time in hours. Okay, so 30 minutes is half an hour, 15 minutes is a quarter of an hour. So in terms of a decimal, okay, it's 0.25 of an hour. Okay, it's 25% of an hour, and we change that into a decimal. It's a quarter as a fraction, and we change them both into decimals, we get 0.25. Okay, B, we're asked, work out Laura's speed cycling to the post office. Well, again, we look over here, our speed equation, we cover up the S for speed, we're left with distance over time. So speed equals distance over time. Go back and write that in here. So our distance that she travels going up to the post office is 4 kilometers. Okay, we're told that up here. The post office is 4 kilometers away as well. The time it takes, well, we worked that out in part A, is 15 minutes. So that's going to be 4 kilometers divided by 15 minutes, which we've had to change into a decimal for how much of an hour. It's a quarter of an hour, so 0.25. And if we divide 4 divided by 0.25, it actually makes it bigger. It gives us 16 kilometers per hour. Okay, if you think about that, 15 minutes she's travelled 4 kilometers, another 15 minutes she travelled 8, another 15 minutes she travelled 12, another 15 minutes she travelled 16, and 15 minutes give us an hour. Okay, for part C, we're asked how long did Laura spend at the post office? Well, she's stationary when she's at the post office, or assuming she is. That starts once the line becomes horizontal and stops once it stops being horizontal and has a diagonal line beginning. So we see here she gets to the post office at 20 past 11. and she leaves the post office at 20 to 12 or 11:40. So the difference between these two times is 20 minutes. And finally D, we're asked work out lower speed cycling back home. Okay, that is related to this part of the graph here. So she's left the post office and she's traveling back home. Okay, and we're going to need to use this time. However long it takes her is from whenever she leaves the post office till she gets back home. So it's from 11:40 to 12 o'clock. So that's 20 minutes. And the distance she's traveling, well, she started at the post office and she's going back home, so it's 4 kilometers she's traveled. And our equation is the exact same as for question B. Speed equals distance over time. That's going to give us 4 kilometers divided by 20 minutes. Now again, we want our speed to be in kilometers per hour. So 20 minutes, we're going to have to change that into a decimal. So it's a third of an hour. Okay, or 33%. 0.3. And that will be a recurring. We'll continue on. That 3 will continue in the decimal. So we can just take it to roughly be as a decimal, 0.333 of an hour. And if we use that, we're going to get an answer of 12.01 kilometers per hour, which we could just say would be 12 kilometers per hour.